Alright, unit 1.4, angles. An angle is formed by two rays with a common endpoint, right? Two rays with a common endpoint. The common endpoint is called the vertex. The rays are called the sides. You name an angle using three letters, right? Always put the vertex in the middle. So this can either be angle ABC, right? Angle ABC, or angle CBA, as long as it has 3 points and the vertex is in the middle. You can only use a single letter if there was only one angle. There is only one angle here. So you could also call it angle B. But if it has more than one angle, you can't use a single letter. You need to use the three letters so we know which angle you're talking about. When referring to the measure of an angle, use a lowercase m. For example, the measure of angle ABC is 60. They're saying that this in between is 60. Right? Angles are measured in degrees. That's what that little doohickey is there at the end. There are 5 basic types of angles. This only lists 4, but I will tell you the 5th one. Alright? There is an acute angle, which means that it's less than 90 degrees. Right? So it's acute angle less than 90 degrees. There's an obtuse angle, and this is more than 90 degrees but less than 180 degrees. This little square means that the rays are perpendicular, and that means it's a right angle. And right angles are always 90 degrees, no more, no less. This one is a straight angle. And it's 180 degrees, no more, no less. And then the last one is called a reflex angle. So suppose it goes this way, and they're talking about this angle, right? If they're talking about this bigger angle, bigger than a straight line angle, right? This is called a reflex angle. And the rule is that it's more than 180, less than 360. It has to be less than 360 because 360 is a circle. These are the 5 types of angles and their rules. Alright, let's look at an example and see what we can learn from looking at our angle. Alright, this angle has 3 points. There's only one vertex. Right, so the vertex is your K, your point K. Your sides are this and this. So your sides can be labeled KL with a ray and KJ with a ray, because those are your sides. 3 ways to name the angle. There is only one angle, so you could call it angle K after the vertex, right? Or you could use all 3 points, JKL, angle JKL, as long as the vertex is in the middle. Or angle LKJ, again, as long as the vertex is in the middle. Classify the angle. It's more than 90 degrees, but less than 180 degrees, which means it's obtuse. It's an obtuse angle. All right, another example. Name the vertex. The 2 rays have one common endpoint. That's S. So your vertex is S. Name the sides. It can be SR or ST. Those are your sides. 3 ways to name it. Again, it's just one angle. So you could put angle S. But if it had multiple angles, you would want to use the 3 points. So angle RST or angle TSR. Classify the angle. This little box means it's a perfect 90-degree angle, so it's a right angle. It's a right angle. Alright, congruent angles. Remember, congruent means equal, right? So if angle A equals angle B, right, then the angles are congruent. This is written as angle A is congruent to angle B. And it would look something like this. They are the same degrees. They are congruent. Right? Again, that would be written as if angle A is equal to angle B, you could say that angle A is congruent to angle B. It's a step further than just saying they're equal. I get it, they're both equal, they're both 75 degrees. But by saying they're congruent, we're saying that it doesn't matter if they look the same. They are the same. So what if I drew one like this and one like this? They don't look the same. But if I say they're congruent and this one is 45, then this one also has to be 45 because they're equal. They're congruent. They're more than equal. All right, your next is angle bisector. A ray, right? An angle bisector is a ray that divides an angle into 2 equal or congruent angles. Right? So, this was one total angle, and this cut it in half. It bisected it. It's an angle bisector. In the diagram to the right, BD is an angle bisector. Therefore, ABD, angle ABD is congruent to angle DBC. Right? ABD is congruent to DBC. They have to be. Because this line, this ray, cut it in half. Perpendicular lines. Two lines that intersect at a 90-degree angle. Right? This is what we're talking about. They create that right triangle. Not right triangle, that right angle. The symbol for perpendicular is an upside down capital T. So, in the diagram to the right, M, line M, is perpendicular to line L. That's what perpendicular means. Perpendicular bisector. A line, segment, or ray crosses, no, a line, segment, or ray intersects to a segment at its midpoint. I don't know. I don't like the way they worded that. Intersects to a segment at its midpoint. Right? Cuts it in half. In the diagram to the right, LM is the perpendicular bisector. How do you know? Because this tells you that this and this are congruent. These are your tick marks. So, if this and this are congruent, then this is your bisector. Right? So, LM is the perpendicular bisector to PQ. All right, let's look at the complicated one here. Let me see if I can make it just a little bit bigger for you. Example 3. Write another name for angle CBF. So we're talking about this angle. So we would want to go FBC, but keep B in the middle because that's your vertex. Name the sides of EBD. First of all, we need to figure out what EBD is. EBD. Alright, and then it says name the sides. You already know what the sides are. It's this one and this one, or this one and this one. Right? So your sides are either BE or BD. You don't even need to see the graph. It's in the answer. The question is in the answer. The answer is in the question. Classify ABC. ABC is a straight line, so it's a straight angle. Give an example of an obtuse angle. Well, it gave us an obtuse angle. It said EBD is what we were looking at. EBD is an obtuse angle. So say angle EBD. There's other obtuse angles. Name two congruent angles. How do you know what a congruent angle is? There's a couple of different ways you can do this. You can do this one and this one, because they're both 90 degrees. Or you could do this one and this one because the line means they're congruent. So let's do that. So let's do EBA, angle EBA, and angle CBF. And name a perpendicular bisector. So if I was looking for my tick marks to see where my congruent segments are, that would mean that this is my perpendicular bisector. So that would be ray BD. That's the ray that cuts this line in half into two equal parts. Right? Example 4. Complicated. Let's look at it. Pause it and see if you can do it without my help. Vertex of angle 2. So we're talking about this angle. The vertex is T. Name the sides of angle 4. This is angle 4. The sides are TZ and TW. Alright, so TZ and TW. Another name for angle 3. So ZTU or UTZ, as long as the T is in the middle because it's the vertex. UTZ. Another name for angle 1. YTX or XTY. Angle XTY. As long as T is in the middle. Classify YTW. YTW has the box, so it's a right angle. Classify angle YTU. YTU. Obtuse. XTU. Acute. WTX. Straight. Name two perpendicular lines. Remember, they're lines that intersect, creating a 90-degree angle, which means that this line and this line are perpendicular. So all I have to do is find a way to tell you I'm talking about these two lines. 2 points make a line. So you only need to do, you could say line YT, and you could say line WT, name an angle bisector. Alright, so this means that this and this are equal, congruent, right? Which means that this bisected the angle and cut it in half. Alright, so all I need to do is name that ray. The angle bisector is ray TU. Read over your notes. When you think you're ready, come get your practice sheet.